What are biofuels? They're combusted fuels created by biomass. They usually replace gasoline, diesel, and jet fuel. Compare and contrast the three generations of biofuels.
The first one is from food crops, the second one is cellulosic biomass, and the third one is produced from lipid production from algae.
Why are biofuels added to regular fuels?
Much of the gasoline is blended with a biofuel such as ethanol. It is used as a blending agent to increase octane, which consequently cuts down carbon monoxide and other smog-causing emissions.
How long does it take for carbon dioxide in the atmosphere to disperse? It is difficult to determine the lifetime in the air of the most significant man-made greenhouse gases because between 65% and 80% of it dissolves in the ocean over a period that can vary from 20 to 200 years. The rest of it can take up to hundreds of thousands of years to disperse in rock formation and chemical weathering. Biodiesel is a fuel which is similar to petrol and fossil fuel. This fuel can be produced by different oils and therefore are better for the earth. The cycle of this fuel is carbon neutral, which means that the CO2 emissions are slim, and with a perfect cycle, the carbon is recycled and reused by the plants that are used for their oils.
We will see the four parts of this lab. We were provided virgin soybean oil and used cooking oil for part 1 and part 2, the titration and the transesterification. But we will focus on part 3, which is cleaning our biodiesel, and part 4, which is energy in the combustion of fuels.
During the titration lab, we determined the amount of free fatty acids in two different samples of oil. We used soybean oil and used oil.
In the transesterification lab, we produced biodiesel from both the oils through a transesterification reaction. The reaction will provide methyl esters and glycerol. The glycerol, which is not needed, will be cleaned out in the next laboratory.
From byproducts and creating an acceptable and usable fuel. During this lab, we cleaned the biodiesel by removing the byproducts such as free fatty acids, glycerol, methanol residues, and soap. The oils were collected from the transesterification laboratory, and the fuels were separated from the glycerol with a transfer pipette and transferred into a graduated cylinder. The glycerol's lower density was made easier for us to take out the oil. The exact amount of oils was calculated and then were added into the extraction flask, one for each type of oil. 20% of the volume of oil collected in water was also added as it is into the extraction flask. The flask was then mixed to blend the components together. The biodiesel will then float to the top as its density is lower than water. The water will then be drained and only the fuel will be left. We amassed 52 milliliters of biodiesel from soy and 51 milliliters of biodiesel from used oil.
We wanted to ensure that we get a forward reaction. Stoichiometrically, 3 moles of alcohol and 1 mole of triglyceride are required for transesterification to yield 3 moles of fatty acid methyl esters and 1 mole of glycerol. So biodiesel yield could be elevated by introducing an excess amount of methanol to shift the equilibrium to the right-hand side. Our initial goal is reached because, according to Le Chatelier's principle, adding additional reactant to a system will shift the equilibrium towards the products, which maximizes the mixture of fatty esters that is produced, which is the biodiesel.
Lab 4 was the laboratory of the energy in the combustion of fuel. For the last part of this project, we burned different kinds of fuel as a way to evaluate how much energy they released. The fuels were ethanol, octane, petrodiesel, and our two biodiesels. The taken steps were to weigh the initial mass of the fuel and its initial temperature. We then placed the fuel under a can filled with water with a temperature probe attached to it as a way to monitor the temperature of the water. After an increase of temperature of approximately 3 to 4 degrees, the spirit burner was then shut off. Afterwards, we weighed the mass of the fuel after heating it up on a stand when noted the final temperature. The equation to use to determine the amount of transferred energy in joules is Q equals mc delta T divided by the difference of mass of the fuels. These are the results.
The most effective fuel is petrodiesel, releasing 27 kilojoules per gram of energy compared to ethanol, the least effective one, releasing 15.5 kilojoules per gram. This means that we'd need a fuel tank almost 2 times larger if we want to travel the same distance on ethanol that we do on petrodiesel. In conclusion, it's true that the advantage of biodiesel is that it is biodegradable and its combustion produces fewer air pollutants such as carbon monoxide, sulfur dioxide, hydrocarbons, and air toxins. The emerging problem now is that the farmers across the world are pressured into growing crops for fuel instead of food. This change drove up food prices and changed land use. In some cases, there have been increased emissions because of deforestation to grow biofuels. The question that arises to the mind right now is biodiesel the solution to our growing fuel demand to ensure a more sustainable practice?